And so what we do is we take it, we liquefy it, and it's distributed within the campus.
Well, you know,
to where it was widespread. And so it's really an enabling technology. If you think about NMR, you know, stuffing people into magnets and taking images of them, right? You think about NMR, that technology would not exist unless helium, liquid helium were commonly available.
well,
So
most people don't realize that when they go into an MR facility, they're going into the room with liquid helium.
yeah, the magnet is a big superconducting
Big superconducting magnet that's cooled to liquid helium temperature. And it's very hard to explain why that is dominated, but it's basically that the magnetic field can be made unbelievably stable if it's cooled with the liquid helium.
Then the power consumption is relatively low.
Yeah, right.
You have to generate a large magnetic field, you need currents, large currents. And if the wires are not superconducting, they're dissipating all the time. And you then have to, you know, you have to plug it into the wall and run it. With a superconductor, you can actually set it up in what's called a persistent mode, where essentially the currents just run round and round and round and maintain the field. And so it's a much cheaper, easier thing. They're willing to pay for the liquid helium to run those magnets that way.
John, some of the materials we have about this helium project. There's a limit.
And put your finger over the hole. Put your finger over the hole on the bottom. No, here. Here. No, I'll show you. So if the fit is so tight that you can see the piston isn't going down, right? You can feel it. Go ahead. See there? Let go.
Wow, that's
Here it comes out.
And that was the so-called cold seal piston.
Yeah.
It expanded the helium gas, and there was no friction as this thing slid up and down. Because if you had most pressure seals, you would have a friction, and that would destroy the efficiency of the device. And that was Sam's original
concept
tool,
idea,
you might say, and learning how to do that. Ships, the drive system for the ship. But then on the other hand, he was working on some sort of paddle wheel boat propulsion process that I never really quite understood. I had the impression that it didn't work very well.
Well, I think it's kind of what he told me one time. That he said if taxpayers ever found out how much money we were wasting down here, they
would be upset, right? Yeah. Well, he was. You know, he started out, when he first moved down there, he worked at the Naval Research Lab in Washington, right down on the Potomac, they just shot them down. And, you know, they weren't doing any real things Sam liked real things. So then he moved down to the engineering lab down at Annapolis. I don't know. They kept changing the name of that. They finally shut it down, so I got lost. Anyway, and so he worked down there for quite a few years, and everything operating from the top end. And this has some that operate from the bottom end and some that up. So here's. There, one of the first pieces of equipment I bought when I inherited the lab from Sam College, he did silver braze of everything. And in the meantime, the technology for tungsten inert gas welding with stainless steel just became unbelievably developed. And I worked for a company that pioneered a lot of that welding, very thin wall stainless steel stuff, and it's amazing. So a lot of the welding in that machine, the prototype of that machine, I did myself. Anyway, I just thought you'd be kind of interested in some of the old machine tools that are kicking around. Let's walk a little bit more and we can see.
Just to let you know, a lot of the stuff was here with
So this is an active research project.
a lot of the stuff was here with Professor Collins.
Is that right?
Yeah.
Yeah.
They have a habit of not throwing stuff away.
We sure admire him.
We have to pay the technicians.
What you can see is when you get to what's called critical state, there is no distinction between liquid and vapor. If you increase the pressure gradually, as you increase the pressure gradually, the difference between liquid and vapor goes to zero. It just looks like the liquid level where you on here. The liquid level just disappeared. You got to match it just right. Hit it right at the point where vaporization, everybody would say, well, just matter. Liquid temperature goes down, liquid always keeps going up. It's pretty interesting because just as you get there, the surface, the density of the surface gets so low, it looks like the surface wave is it sloshes, but it sloshes almost still. Really, really interesting. So that was one of my real projects to make that demonstration. So undergraduate, you see it, I think half the graduate students have never seen anything in CO2. So we can show you the critical point state in here, but it's a lot harder. Carbon dioxide. Yeah, well, okay, well, we saw the commercial design of his demonstration of feasibility. And you see, they made it all look really nice and all good work parts. And you can see the machine that we looked at down there was not didn't look like that tank over there. It was. You know, sort of.
Okay.
In other words, they dressed it up a little bit.
They dressed it up very much. Okay. Sam used to say, "Well, you know, what I really worry about is that they redesign it to the point where it won't work anymore." You know, the subtleties that if you didn't realize they were there, they didn't look like they were important, so you would polish over them and. He used, that was kind of his joke about particularly the industrial companies that he worked with. ADL was better like that. They had learned the lesson.
She's an old educator. We're circling now and introducing each other. How many children do you
John,
have?
want to close the door? Or
If you like, I will.
So
Just getting
welcome
comfortable.
to MIT. I think you've been going around a bit today.
Yeah, we've had two good guys.
I just thought we ought to bring the delegation from the Collins family over. They've been such a phenomenal supporter of MIT.
Absolutely,
And,
we really appreciate it.
the Sam Collins tradition continues on, and we showed her the part of MIT that is, you might say, in Sam Collins's mode, which doesn't match some of the modernistic, fancy computer technology, great screen. But we did look at the computer control on the helium liquefier that the students made and put together, and it makes it run by itself at night. It shuts itself down.
That's the way the Sam Collins room came about.
Right.
And it just helped me a
Have a
little
big
bit.
flow of people.
We've got good, and they cover all of our overhead expense and things like that as far as insurance on the material in the building, and it's very open. It's public's got access to it, and they've been very the board, the library board, has worked with us real well, and the director with as well. So that's the way it came about. Otherwise, we'd have done it 30 years ago. But it's been an ongoing thing, and we're trying to get our young people involved in it as well, because after Frank's gone, that's about it. For the nieces and nephews, then we got to get down to that second level.
So any other engineers in the making here?
Well, had one graduated, of course, he graduated years ago. There may be one or two in the making, we hope. I can get him out of UT jacket here. No, I'm just kidding.
Well, we know a good school that they can go to.
Yep.
On Sam here, so it says, so this is 1946, Samuel C. Collins and Collins, effective helium liquefier that provides a reliable and affordable supply of liquid helium for research in superconductivity and semiconductors. So sort of touching on also the, not just its contribution then, but what it enables in the future, which is really remarkable. And I think really signature of the department. And I think this is a picture from the archives. What I thought I'd do is when we actually have this in a little hardbound, I can send it to you.
Right.
And you can kind of open it up in your museum part, or not the whole thing, but open it to that page or something. That might be kind of cool. It would. But we've really been trying to really reflect and document some of the historic moments in the department, and certainly Professor Collins' work was a clear winner.
I don't know, whether on the way back, we could probably come and see, for example, we have the undergraduate laboratory downstairs. There's a lot of, for example, Mary mentioned the 2007 competition occurs, this picture in the front. We can actually, on the way back to the
Reality, which is in certain elements of the mechanical engineering department that has always been the tradition, not just to think about it and do it on paper, but make it really work. And of course, what you discover is that the way you think about, the way most of us think about these things are simplifications of reality, and